Hi class, welcome to Module 6. This week what we're going to be talking about is something called linear regression. Basically what linear regression is modeling the relationship between two variables, an x and y variable. And when I say modeling it, I mean fitting it with some type of equation of a line that fits or goes through the data. In the videos this week, what I want to do is I want to go through two examples from your homework, problem number 3 and problem number 7, and show you how to use StatCrunch as I have been in the previous videos to answer many of them very quickly and very easily. So let's take a look at problem number 3. For the accompanying set of data, I want to do three things. I want to draw a scatter diagram for the data, compute the correlation coefficient, determine whether there is a linear relationship between x and y. Okay, so the first one says draw a scatter diagram for the data. All right, so what I want to do is I want to click this button, and here's the data. So I want to load the data up in StatCrunch. So when I load the data up in StatCrunch, what I want to do to get a scattergram is I want to go to Graph, and over here it's just called a scatter plot. All right, so I'm going to click on that. The x variable is under x, the y variable is under y, obviously, and I'm just going to hit Compute. And you should see the data kind of looks like this. Now, what stinks a little bit is if you look here in the class room, the scatter diagrams or scatter plots are all centered at the 0 axis. But when you go to StatCrunch, they're not. So it looks like I have two low ones when x is equal to 6, it's at 2 and 6, two high ones, and then one down over here. So what you have to unfortunately do is look at the scatter plot that shows that. And it looks like it's number C, 2 low, then 2 up high. Oh, sorry, it looks like D, 2 low, and then 2 up high, and then 1 out here. Like you can see D looks like this, but just including down at 0. So I'm going to hit D, check my answer. That's good. Excuse me. Now compute the correlation coefficient. So I'm going to go back into StatCrunch. Oops, sorry about that. I'm going to go back into StatCrunch. And to compute the linear correlation coefficient, you're going to hit Stat. You're going to go down to Regression, and it's simple linear. All right, so Stat, Regression, simple linear. This will be the option used the most this week. All right, and it's incredibly useful. And whenever you don't know what to do this week, that's what you should default to: Stat, Regression, simple linear. So I'm going to click on that. It's going to say the x variable is under x, y variable is under y. You're going to hit Compute. All right, now you're going to see this print out with a bunch of stuff, all this crazy stuff. And we'll talk about this in the next example, but what you're interested in is the correlation coefficient, which is right here. So it said round to 3 decimal places as needed. So I'm going to go to 0.149. And look, we got it right. All right, the next one says determine whether there is a linear relation between x and y. Okay, so the first one here, let's just go through what the options are. Because the correlation coefficient is, here it looks positive, and the absolute value of the correlation coefficient, well, the absolute value of a positive number is just still a positive number, all right? If it's negative, just remember that if the correlation coefficient is negative and it asks you the absolute value of it, it turns positive. Is blank, so it says not greater than the critical value. So you click over here, all right? And it opens up this critical value table. Well, what n represents is the number of paired data you have. Well, if you look back at the data set, I have 1, 2, 3, 4, 5 data values. 1, 2, 3, 4, 5 paired data values. So you click here, and it looks like when you have 5 data values, this critical value for the correlation coefficient is 0.878. Well, our correlation coefficient is not greater than the critical value of 0.878. And what that means when it's not greater than is no linear relation exists between x and y. So I'll check my answer. I got it. So now it depends if it's greater than, so like if this had been a number like 0.900, we'd say it is greater than and a positive linear correlation exists. But if the value was negative, we would just say a negative linear relationship exists. All right, so just remember when you go to the critical value table, how many ever paired data values there are? Like you can see there are 1, 2, 3, 4, 5. Go to the corresponding value there. So if there were like 9, this would be the critical value, and so on. All right, let's skip ahead now and let's look at problem number 7, right? Because a lot of your problems in the homework will look like this one. Right? So I'm just going to close my stack on. All right, so an engineer wants to determine how the weight of gas-powered cars, X, so that's what X represents, affects their mileage. All right, and that's going to be given by the Y variable. The accompanying data represents the weights of various domestic cars and their miles per gallon in the city for the most recent model year. So let's complete parts A through D below. So let's click here to view the weight and gas mileage. Right, so these are the weights of the cars, and here's the corresponding gas mileage. So what I'm going to do is I'm going to open this in StatCrunch. So just so I have my data in. The first one says, all right, let's find the least squares regression line treating weight as the explanatory variable, that's X, and miles per gallon as the response variable. Response variable is Y, right? So round the X coefficient to 5 decimal places as needed, that's the value, the slope in front of here, and round the constant to 2 decimal places, all right? So the way you're going to find the linear regression line is you're going to go stat, regression, simple linear. So it says your X variable is weight, your Y variable is miles per gallon, and all you're going to do is hit compute. All right, so if you look here, all right, this is going to say that your equation, your miles per gallon Y is equal to, this is weird, they put the constant first, and then this is the slope. All right, another way to see it here that's a little bit better is the slope is right down here, it is the X value. So it said go out 5 decimal places, so it's negative 0.00687, but that 5 is going to make it an 8. So when I put it in here, I just have to make sure to change it to an 8. All right, that's 1, 2, 3, 4, 5 decimal places. I'm good. And then going back in here, the intercept, it said go to 2 decimal places, is 42.91. So I'm going to put that in there. And look, gave me my regression line very, very easily and quickly. So that's great. So let's interpret the slope and y-intercept if appropriate. All right, and let's choose the correct answer. All right, so here's the thing. It's not ever appropriate to interpret the intercept, okay? So you're going to know that right here. It's not appropriate to interpret the y-intercept. In regression, it has no meanings. So you're going to interpret the slope. And it's for every pound added to the weight of the car, gas mileage in the city will decrease by 0.00688 miles per gallon on average. That's what it means. And you can see we got it right there. The reason I didn't put the negative in there is because it tells me it already decreased. All right, a certain gas-powered car weighs 3,500 pounds and gets 21 miles per gallon. Is the miles per gallon of this car above or below the average of cars of this one? All right, well, what Y bar tells us, all right, or Y hat, it tells us the predicted gas mileage if you know X. So X is the weight. Well, they're telling us what the weight is. So all we're going to do is we're going to take that and plug it into our calculator. So it's minus 0.00688 times the car weighs 3,500 pounds plus 42.91. So it looks like, hold on, Oh, yes, and I'm sorry, it gets 21 miles per gallon. So what the y hat, sorry for my pause there, is telling us is that we predict that it should get 18.83 miles per gallon. And this is saying it gets 21. So is the mile of a gallon of this car above or below the average? It looks like it's above because what our calculator is saying is we should get 18.83. Sorry for my pause there. So we got that. All right, so the next one, would it be reasonable to use least squares regression line to predict the miles per gallon of a hybrid or electric car? All right, why or why not? Well, this model worked when we were only given gas-powered cars, all right? So no, because the hybrid is a different type of car. So we got that. So just remember as you go through these problems, um, always try to use that regression in StatCrunch, this stat, regression, simple linear. And it will help you find all these things like the correlation coefficient and the equation of the least squares regression. As always, if you have any questions, please post in the classroom and I'll respond as quickly as I can.